This video lecture addresses image interpretation. Specific vocabulary is used when discussing image interpretation in remote sensing, and the terminology may not be intuitive to the beginning student of remote sensing. Remote sensing images differ from what humans are used to seeing from the ground. Remote sensing captures data from an overhead view and can include radiance outside of the visible spectrum. Often, remotely sensed images have unfamiliar scales and can be presented at unfamiliar resolutions. After reviewing this lecture, the viewer should have a better understanding of terminology used in image interpretation. Remotely sensed images differ from what humans are used to seeing. For example, remote sensing uses an overhead view and is capable of capture and display of radiance outside of the visible spectrum. Remote sensing deals with unfamiliar scales and unfamiliar resolutions. There are four key tasks common in image interpretation, including classification, enumeration, measurement, and delineation. Classification is where objects, features, or areas are assigned to classes based on appearance in the imagery. This includes detection, which is basically the ability to determine presence-absence. Recognition, which includes identity to a specific class or category. And identification, which is when there is confidence in specific details in classification. In image interpretation, enumeration is the counting of discrete items, and measurement is finding a number that describes the size or amount of something. Delineation is where the analyst draws outlines of regions or objects. In the past, much of delineation of remotely sensed imagery was done by hand. Today, some computer-driven digitization is possible, though it is still common to hand digitize using aerial imagery as a base layer. The 8 common elements of image interpretation include image tone, image texture, shadow, pattern, association, shape, size, and sight. These 8 elements should be used whenever an analyst is interpreting a remotely sensed image. Image tone refers to the lightness and darkness of an image. The Japanese Association of Remote Sensing, JARS 2010, describes image tone as, quote, the continuous gray scale varying from white to black. In panchromatic photographs, any object will reflect its unique tone according to the reflectance. For example, dry sand reflects white, while wet sand reflects black. In black and white near-infrared photographs, water is black and healthy vegetation light to gray. In these images, you can see the differences in gray tone and black and white areas of the images. Image texture refers to the roughness or smoothness of the image. JARS 2010, page 152, describes image texture as, quote, a group of repeated small patterns. For example, homogeneous grasslands exhibit a smooth texture. Coniferous forests usually show a coarse texture. However, this will depend on the scale of the photograph or image. When you look at each of these 6 images from the University of Puerto Rico at Mayagüez, what texture do you see? Some areas are smooth, others appear rough or three-dimensional. Quote, shadow is usually a visual obstacle for image interpretation. However, shadow can also give height information about towers, tall buildings, etc., as well as shape information from the non-vertical perspective, such as the shape of a bridge. JARS 2010, page 152. For example, consider the shadow from the Washington Monument in the image in the upper right. You can notice the direction of the sun and also make some inference regarding height, time of day, and seasonality based on the shadow. Pattern is somewhat self-explanatory. Pattern refers to the arrangement within the remotely sensed image. In these examples, you can identify geometric shapes and arrangements like street grids and natural features. Jarge describes pattern as, quote, a regular, usually repeated shape with respect to an object. For example, rows of houses or apartments, regularly spaced rice fields, interchanges of highways, orchards, etc., can provide information from their unique patterns. Association suggests what else may be nearby. In this example, we see the Hoover Dam, and as it is a well-known landmark, we have an idea of what else is nearby. Even if we did not know the name of this dam, recognizing it as a dam would also inform the interpreter that there is a reservoir upstream and perhaps a hydroelectric power station and associated power lines. As JARS 2010 describes, quote, a specific combination of elements, geographic characteristics, configurations of the surrounding or the context of an object can provide the user with specific information for image interpretation. Shape can help the interpreter with object recognition. As JARS 2010 notes, quote, the specific shape of an object as it is viewed from above will be imaged on a vertical photograph. Therefore, the shape looking from a vertical view should be known. For example, the crown of a conifer tree looks like a circle, while that of a deciduous tree has an irregular shape. Airports, harbors, factories, and so on can also be identified by their shape. In the 6 images from the University of Puerto Rico, you can clearly depict common shapes like an airplane and a highway. The image to the bottom right from the Big 8 Elements of Image Interpretation PowerPoint slides shows pyramids in Egypt from space. The image analyst can use commonly recognized features to identify the size and scale of objects. For example, since baseball fields have a standard distance between bases, an analyst can use that to determine the size of other features in the image. As JARS 2010 notes, quote, a proper photo scale should be selected depending on the purpose of the interpretation. Approximate size of an object can be measured by multiplying the length of the image by the inverse of the photo scale. The 8th element of image interpretation is sight, which provides detail on topographic position. Sight includes elevation, slope, aspect, exposure, and adjacency to known objects. The University of Maryland, Baltimore College, UMBC, no date notes, quote, how objects are arranged with respect to one another or with respect to various terrain features can be an aid in interpretation. Aspect, topography, geology, soil, vegetation, and cultural features on the landscape are distinctive factors that the interpreter should use when examining a site. The relative importance of each of these factors will vary with local conditions, but all are important. Just as some vegetation grows in swamps, others grow on sandy ridges. Agricultural crops may like certain conditions. Man-made features may also be found on rivers, for example power plants, or on a hilltop, observatory, or radar facility. To recap, the 8 common elements of image interpretation include image tone, image texture, shadow, pattern, association, shape, size, and sight. These 8 elements should be used whenever an analyst is interpreting a remotely sensed image. The following references were consulted in developing this video lecture.